So, good day, everyone. Today, we will dive into the core concepts of ECE 332, which is the Communications 1. So, I am Irene Julia Magahigan from the Bachelor of Science in Electronics Engineering. For today's discussion, let us know how information travels from the source to its intended destination. So, along with the among other technologies behind it. So, let's get started. So first, let's discuss the elements of communication systems. Imagine na siya. So you should know that a communication system is a highly versatile diri sa ato ang generation. So it can operate over both short and long distances using mga wired or even mga wireless transmission media. So for us, we'll need to take note that any failure in just one component can actually affect or completely affect the entire system. So to understand it easily, let's trace kanang flow of a signal based on its kanang block diagram. So everything starts with the source. So this is where the message originates, which can be a human voice, a television picture, or even an email or a data. So our source data is non-electrical like our voice. So an input transducer must convert it into an electrical waveform known as a baseband signal or message signal. So physical devices like microphones or computer keyboards do this job. So for let's next is the transmitter. So its main function is to modify the baseband signal so it can be transmitted efficiently. So inside sa transmitter, maka-find taog subsystems like A-D converter, an encoder, and a modulator. After leaving the transmitter, the signal goes into the channel. So this is the medium of choice that conveys the signal over a distance. So sa channels, we have two types ani. So we have the physical channel. So sa physical channel, when there is a physical connection like mga twisted copper wires or mga coaxial cables. So naputay pangaduha which is the wireless channel. So if wireless channel, the transmission is through the air, dili katong ginagamit og mga wire, completely wire-free, just like mobile communications at mga cell phones. So while traveling through the channel, so nitravel na sa channel, dili gyud malikayan ang noise. So noise is an unwanted or random signal that interferes with our required signal. So it can strike at any point kana nga kind of noise, but it has the greatest distorting effect right inside the channel. So once kanang signal reaches the other side, the receiver takes over. So since the signal was distorted by noise, the receiver's primary job is to reconstruct the original message signal using a process called demodulation or detection. So which is simply the reverse process of the transmitter's modulation. So finally, after the transmitters, we have to reach the destination. So, ang destination is the final stage that converts the electrical message signal back to its original. So, recognizable form na siya. So, for example, sa radio broadcasting. So, sa radio broadcasting, the destination is a loudspeaker acting as an output transducer to bring back the original sound. So, muna siya yung mga example, ana. Now, let's proceed to modulation. So, by definition, ang modulation is the process of altering a high-frequency carrier wave's characteristics, specifically its amplitude, frequency or phase in accordance with our low frequency message signal. So nganong kinahanglan man ni nga siya nga ato nga buhaton. So it is absolutely crucial for practical antenna sizing and noise reduction. So basically, ang modulation is classified into two main types. First, we have the analog, and then second is we have the digital modulation. So in analog modulation, a continuous sinusoidal signal is used as the carrier. So we have four basic types under this category sa ato nga analog. So first, we have the amplitude modulation, or what we call AM. So the amplitude of the carrier is varied in accordance with the amplitude of the message signal, while frequency and the phase remain constant. So frequency modulation is the next. So the frequency of the carrier is carried based on the message signal's amplitude, while amplitude and phase stay constant na siya. Here naman sa tuwang phase modulation, or what we call the PM, the phase of a carrier signal is varied accordingly. Sa analog pulse modulation naman is standard AM, FM, and PM used continuous carriers. Pero, diri, the carrier is a discontinuous series of pulses. Like examples, include na siya sa mga pulse of amplitude modulation, or what we call the PAM or the PAM, pulse width modulation, PWM, and the pulse position modulation, which is the PPM. For highly efficient communication with high noise immunity, we use the what we call digital modulation. So the foundational technique here is pulse code modulation, or what we call the PCM. So ang PCM converts an analog signal into a digital signal, meaning the 1S and the OS producing a coded pulse train. So muna siya the two types of the analog and the digital. So now, let's talk about the bandwidth. So bandwidth is the range of frequencies occupied by a signal, or the total width allocated to a channel. So mathematically, it is the difference between the highest and the lowest frequency components. So, imo na silang minus na siya. So, it is measured in hertz and directly dictates your data transfer rate. So, now, para dagin ta sa channel and allow multiple users to use it. So, we use multiplexing. So we have frequency division multiplexing, FDM. So this is an analog multiplexing technique where ang total bandwidth of a physical channel is divided into distinct non-overlapping frequency bands. So each user gets their own unique frequency slice all that time. So dili jud na siya magkaparehas, but it is unique. So we also leave guard bands, or empty spaces, between channels to prevent crosstalk. So think of it like kanang tuning into different radio stations. They all exist in the air simultaneously. So para magkalay silang frequency assignment. So muna siya all about the frequency. So we also have time division multiplexing, or the TDM. So this is a digital process. So instead of splitting the frequency, users share the exact same frequency channel, but they do so by taking turns over time. So the entire bandwidth is dedicated to a single user for a fraction of a second inside a tiny time slot. So we can do this rigidly via synchronous TDM, or dynamically via asynchronous TDM based on the demand. Let's talk about radio frequency spectrum. So RF is the portion of the electromagnetic spectrum widely used for wireless communication, spreading between 3 kHz and 300 GHz. So practically, all transmission systems from TV broadcasting to mobile networks and satellites work here. Then we also have um, the how to calculate the wavelength of a signal. So we use the formula as you can see in the screen, where v is the velocity and the f is the frequency. Next is a quick breakdown of the RF bands from our reference table. So none as you can see on the table listed. So we all always remember, as the frequency goes up, the wavelength goes down. So consequences, higher frequency bands like UHF and CHF require mga much smaller physical at the antennas compared to VLF or LF bands. So, mo na siya ato ang kinahanglan nga i-remember for us to know it well about the hertz and also the bands. And that concludes our look into the foundations of the communications. So from basic blocks to the RF spectrum, these elements ensure that the world stays connected. So mugang natay we have the easy nga course. So daghang salamat for listening, and I hope you've learned something valuable today's discussion.